So here with our next talk, I'd like to welcome Ben Stav, and he's going to be presenting from trace to triage. But if we can go back one slide, I do want to point out one important thing. We do all our questions here, not through the audience, but through this app called Slido. So if you go to slide.do and type in the keyword BSidesSF 2025, again, BSidesSF 2025, it'll get you straight access to this room. We're in Theater 6. It's very important, Theater 6. That'll get you to the right spot. And you can type in your questions as they occur to you. And if they're really popular, if you see a question that fits what you want to ask, just upvote it. And we'll make certain that that one gets answered in the first set, if there are. All right. Well, with that, let's give it a go. Hand it over to Ben.
Thank you. So, hello. I'm Ben, heading architecture at Mingo. So previously, I've done stints in application security, more specifically web application security. A lot of engineering, system design, architecture, but really at heart, I'm like a JavaScript kid. And yeah, right now, architecture at Migo, which is an ADR platform. That stands for Application Detection Response. Marketing will hate me for saying this, but basically we do observability for security. And that basically means that we help organizations understand what's happening in their production so they can confidently and quickly respond. Now, before we even start talking about what we're going to talk about, I'd like to do something with you first. I'd like us all to do a deep collective breath. Can you do that with me, please? So let's go. That was nice, wasn't it? Thank you for doing that with me. Because AppSec's hard. Like, for real. Like, it's like 10 different disciplines in a trench coat. You have so many stakeholders. You have like your boss and your teammates, obviously, but there's also engineering and operations and DevOps, and you have like finance and compliance, and you have P0 thrown at you from all over, you prioritization and triage, and blah. And it's a lot to unpack, and we're not gonna unpack it all in 45 days, let alone like the 33 minutes that we have left. So we're gonna focus on one specific aspect of AppSec, and we're gonna figure out how to do that better. And that is like making sure you have everything that you need to respond when things get real. So here's what we're gonna do. We're gonna do 3 things. We're gonna figure out what your applications are composed of. We're gonna make your life easier, and we're gonna make sure you have absolutely everything that you need. And it's gonna be like with a small demo of an RCA, so sacrifices to the demo gods are appropriate now. Okay, so picture this. It's day 0, you've just joined a new organization. There's nothing in place. There's like no security in place. And so pawn to E3, your move, what do you do? Well, from me, in like my hat both in architecture and development and security, I like to just collect a lot of stuff and then iterate and figure out. That's like the data-driven approach, yay. So what does that mean in security, especially application security? That's inventorying. That is understanding what you actually have so you can do your job and protect it. And that's like 2 things. You gotta figure out what you even care about, and then you actually gotta gather that all over and over and over and over again. So what do you care about? Well, it's AppSec. That's application security. Obviously, you care about applications. Okay, cool. What are applications? Well, there's everything in the App Store. But that's not quite it. That's not quite it, right? Because you're a B2B SaaS. So for you, an application is something else entirely. Or you could be like selling vending machines. So for you, the definition of an application is vastly different than what I would have anticipated. But something that I think we can all agree on is that we have a bunch of services which are encapsulations of some logic. They could be talking to one another. And there's the outside world. So there's data coming in and potentially interacting with your bunch of services. And there's data going out, interacting with the outside world. And there's some shared infrastructure going over like that this is running on. And these are all the things that you have to care about when you care about application security. But that is not all when you're doing AppSec, right? Because you're not just doing the deployment, you're in charge of the full SDLC. So you've got a bunch of developers, they're pushing code to some repo that is being pushed out to some artifacts that's being shipped to some hardware. Now, the exact diagram is probably not this for your organization. It's probably like 700 different steps that are intertwined in some way. Maybe there's even people, like shipping things out from their machines directly or stuff like that. But these are also things that you need to care about, right? But that is not all, because we as security personnel also create artifacts that you need to keep track of. These are like examples for pen testing and auditing, but there's also like vulnerability management, there's scanning results, there's a lot of findings that we need to keep track of in order to actually do our job. Okay, so how do you actually do that? It's a bit difficult, isn't it? So there's a lot of things that we want to keep track of when we're actually inventorying. And how do you do that? So I've picked one example, which is an API inventory that we all, if we're like doing especially web applications, just have to do. And there are quite a few methods for doing that, right? You can go ahead and like go and dump some API schemas if that's relevant. Maybe you go dumpster diving through your source code, right? And you go like, oh, so that's how you define routes of in Fast API. Who knew? You prowl through whatever existing tooling you already have. Maybe there's something in place here. A source that I will visit on later, but I find often overlooked is monitoring. Because even if your application, if your business doesn't care about security, they probably care about uptime or some measure of performance. So they may have dashboards available for like, hey, is my site up? Or hey, what's my P95 latency to make sure that it's not 10 minutes? Finally, you may find some overzealous engineering manager or something like that that documented everything in like an Excel sheet. And it may be a bit better than strewn over like 100 pages in Confluence. But make friends with that guy. So you've done that. You've collected everything from multiple places. So you've understood that nobody actually understands what's going on, right? There's organizational chaos all over. There's so many gaps, and developers may not necessarily understand what is actually being shipped to production. DevOps may not completely understand what's actually the intent here. And that's part of your job to reduce some of this chaos and not add to it. And again, it's like very easy to understand how this happens once you go past the two people in the garage working on something small. What you need to do at this point is you gotta automate everything. Like everything that we've said, make it run on a schedule. Everything that you've collected manually, you need to buy or build a tool that does that. So when we're talking, for example, about API inventorying, then if you're the one who went over the source code and extracted endpoints, there are tools to do that for you. Or if you're the ones who are dumping OpenAPI schemas and validating them and doing all kinds of stuff, make that run on a schedule. Cool. Now, you've gained an understanding of what your applications are composed of, and audits and tests are like your come to Jesus moment. That's when like you get a feeling for how right you are. Like, was my understanding correct? Did I build up the correct mental model? I got a result, a finding of some sort. Was this in a place that I expected? Like, oh yeah, this is like iffy. We're gonna be busted there. Or is it like, oh, I completely overlooked this aspect? And that's like the data-driven approach. You've got some new findings, you've inventoried them, you're making sure to incorporate that inside of your process. So You have your inventories. Everyone's, harangue inside of the corridors. Turns out that you've got all of these and they kind of suck. And that stems for a few reasons. Tools are very, very different from one another, and applications are very, very different from one another. Just as an example, let's say that you have a company down the hall who does like CRMs for kittens. Amazing idea. They're running virtual machines on like Java monoliths, what have you. They care about listing EC2 instances and subnets and VPCs and all of that. Okay, there are lots of tools to do that. But you're doing CRMs for puppies. Awesome idea. And what you are running is like auto-scaled hosted Kubernetes and all of that. So you don't really care about like your virtual machines. They're cattle to you. And the subnetting that you really care about is like inside of Kubernetes, not outside of it. So for you, listing EC2s is just pure noise. Like you don't really care. And down the hall from you, like on the other side of the street, maybe there's a company who does CRMs for lizards, and they're running all like Lambda Edge. So for them, the concept of listing EC2s and subnets is just ludicrous. Like, what are you even talking about? So for them, a tool that does the very easy and understandable thing of let's list out all of your EC2s is just not interesting. There's also the aspect that tools really don't want to talk to one another. Like, again, API inventorying. You have just two things. You have source code scans, and you have scans from the outside, like runtime, something hitting your endpoints. So you've got two lists, right? How do you correlate them? The tools are likely to not be in your favor here. Like the API scanning tool from the internet, they don't really understand how source code defines endpoints. They're not going to match that up. So that is mostly left to you to understand how to do all of these correlations. And so that sucks, but we're the users. Like all of us here are the users, and we have budgets, and we can choose how to spend them or not to spend them on vendors, right? So as users, you gotta demand better tools. Like as an industry, security is not very, very good at cooperation. And that's something that we need to improve. We're in a better place, and we're gonna talk a bit about that, but looking over the last like 5-10 years, we've started making standards. So we've started understanding like, hey, how are we going to list out vulnerabilities or dependencies? Suddenly an SBOM has a format? Wow, that allows me to vendor shop and have like keep my data with me? That sounds exciting and boring at the same time because it should be the obvious thing. So that's something that we have to demand of our vendors. Despite all of these, how can you still build quickly? So I'm gonna offer like 4 things that you can do to still iterate and make sure you have everything that you need. So first, as we've mentioned, use tools that you actually understand. If your lizard's building a CRM and you don't need something listing virtual machines, don't use it. Just stop. You don't have to. Nobody's forcing you. Use your budget in a way that's appropriate for you. Use the tools that will actually help you and your team to rapidly succeed. Second, as we've mentioned, automate everything. Make things run on a schedule, make it run cron, make it run CI, like make the robots work for you. The robot overlords will uprise and throw us, so we gotta use our time on this earth while we can still lord over them. Third, and that is more soft, you gotta make sure you have everything that you need to affect processes inside of your company. Because if you have a methodology or a vendor that you want to use, but you don't have the capital to actually implement that, then you'll slow things down. You got to make sure that you can get to the point where you can affect changes and you can affect life cycles so that you can get results. Because once you get results, it's easier to sell things inside your organization. Because you're saying, hey, I did a thing and it made your life better. So I'm going to do more things, okay? Cool. And fourth, this is something that we really need to be better at, is building relationships inside of a company. Like historically, security and DevOps and engineering are like a painful triangle of distrust and, you know, some grumbly feelings. It doesn't have to be that way. Like working together and making sure that we're all on the same page and we're all striving towards success is important. Now, one tool for actually doing that is to understand that what we do is cool and to actually talk to people and, you know, you found some cool stuff out, not approach it from a haha, you suck angle, but like, hey, I found this cool thing. Let me share this with you. And when you approach people who really enjoy their craft and you can tell them, hey, I found this cool thing, they'll be interested in it because we like cool, shiny things, right? And like they'll also share stuff with you so you can be better understand how things are actually running so you can do your job better. And this creates like an interesting thing, a dynamic where you can actually help people inside your organization be better security people. So you don't have to do your job as much because other people are doing it for you. Because if developers are being better security people, and if DevOps are being better security people, you can deal with other stuff. And that's awesome. So I'm mentioning all of this, like, yeah, just do things, yeah. But it's actually hard, it's actually difficult, especially if there's already like entrenching of how things work. So yeah, all of this and all of that is like DevSecOps and all of that. It's difficult, it takes time, it's not done over a day. Moving on. So we've had our inventories, we've built an understanding, we've made friends with everyone, and now we're in like the dry run. Now we're in like the interesting territory of you've got pen test results, or you just got audited, or you just integrated a new tool and you have a bazillion new findings. What do you do? Well, if you've ever looked at like a list of like an audit or a pen test or whatever, you just immediately get the feeling that, yeah, I don't care about all of these. Like some of these are interesting and some of these are just, yeah, okay, whatever. And it is up to you to prioritize and give an understanding of like what's a P0 and what's a backlog item. And you need to have the tools and knowledge in order to both for you internally understand this difference, but also talk your organization into understanding the difference. Because if you're marking something as a P0, you want to make sure you have data to back it up. So have like a few things to help you evaluate a finding. So first, you have to understand what it even is. Then you need to understand the impact that this has. You got to assess the risk that it poses to your organization. And then you have like two decisions to make. First, if you want to delegate this to be fixed, like either you do it, your team does it, you're opening a ticket, whatever the process is for your organization. And then you have to decide if you want to mitigate it in the meanwhile. Because, for example, if this is truly a P0, everything is on fire, you may not want to wait until it's fixed to not be vulnerable to this. So either it's like a configuration of some sort or an alert of some sort, whatever you need to do to make sure that you're not impacted. So how do we actually get the data we need to like answer these questions, to understand all of these? Here, like context is king. Just, you got a finding. We have like a visceral understanding of our environment. So just the answer for which service is this in, like already gives you either like chills down your spine or okay, whatever. Because if this is like your most public, most external, most, vulnerable, most like, oh no, application or service, that's very different from, oh yeah, that's where someone orders sandwiches and the whatever and it's behind the VPN, who cares? Then you go through like, is this something that's locked down like behind 7 VPNs and 1,000 security rules and all of that? Or is this like, oh yeah, we'll get to it when we get there and you never got there? And finally, what is it accessing? What kind of data is passing through this? Because, you know, even thinking about defense in depth, you want to make sure that even if this is like a mild vulnerability, if this were to be exploited and done, you know, pushed into something larger, how screwed are you? Like, is this the most sensitive data in your organization, or is this like, okay, is this possible to do some interesting lateral movement for this, or will this be okay? Now, how accessible is this, and can just anyone exploit this? Like, can I open up a browser tab and just get to the thing and run it? Or do I need like specific admin credentials and all that? So this is just a very, very, very partial list. It should be like more specific to your organization and how you run things and how you define applications. Just as we said, it's like a very specific thing. So, okay, so we got our findings, we understood what we need to answer. Well, how do we answer these questions? So we can do it like the good old days. You can go dumpster diving for logs. You can read code out. Like say, okay, so this calls that, calls this, blah, 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 and oh, this was not passed through the middleware, blah, blah, blah. Maybe you have reproductions. So if your auditors were amazing, they'll give you some way to repro this. And if you got friends in engineering, then maybe you can even run this locally and step through with a debugger. Oh, that's always fun. Then you can do stuff like analyzing your security groups in place and all of that. And then you were like, oh no, I did the thing for staging. And of course, like staging and production are different. And you just want to yell out to the sky because AppSec's hard. And there's just so many things to answer, like a basic list of like, I got a finding, so I need to do something. It's hard. So I'm gonna propose something as part of our automating all of the things. Remember how like 10 years ago, we started inventorying our entire environment and understanding what we have? So let's use this data. Let's make it work for us. And what I'm gonna do is I'm gonna take an example from modern observability and show you like 2 tools, profiling and tracing, to show you how like you can get a lot of these answers with maybe tooling that you already have. So it's okay if you're not familiar with profiling and tracing. I'm gonna lay it through and explain what they are. Let's start with profiling, especially sampling profiling. And that is relatively easier to understand because it's stack traces, just a bunch of stack traces. That's sort of how it looks like. So what we're seeing here, you have something that goes to your application and asks, hey, what functions are you running? And you can see like a list of, oh, this calls, this calls, this calls, this calls, and blah, 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 blah. And that is quite cool. The original purpose of this as an observability tool is to answer questions like, what's taking so long? Like, do you have a specific query that's taking you like, you know, a minute to run? Or that's a specific function that's like quadratic complexity and does a bunch of stuff. But Dunning or security hat, we can do something a bit different, which is understanding what's actually happening inside of our applications at runtime. And that's kind of cool because remember how we like dived into the source code, either to understand what's actually going on or to do some reproduction or whatever? Like, you know how you go through code and you build a mental model for who's calling who? That's just can be done for you with actual data inside of your production. And especially like over the past few years, the concept of continuous profiling, which is running this kind of thing without a lot of performance overhead, has gained a lot of traction. So this is a thing. And that's kind of cool because you may already have this running. So profiling gives us some depth, an understanding of what happened. Now, tracing is both a very simple thing and it could be a bit complex. So work with me here. What we have is a bunch of events. So let's go through like a sample request and figure out what's going on there. So we have our service and it's like, oh yeah, I'm listening to /foo and I just got a get request. I'm the server, I'm on service A, we just started out. As part of handling this query, we're executing like a DB statement. Cool, so we're handling a request, inside of it, we're running some query. Cool, query's done, we're doing like an HTTP request to another internal service called service B. Now, service B is handling this request and it's doing some logic. So we had a request, it executed a DB query, and then executed an HTTP request, and now we're handling this HTTP request. And once that's done, we have like a map of who's calling who. So an understanding of what's actually happening, again, a different kind of understanding of what's actually happening inside of production and which service is calling which servers and how. So that's how it looks more in real life. So what we're seeing here is we have a shop backend, that's our service. It's doing a bunch of stuff, and then it's calling cart service, whatever. And then it's calling an authentication, and that it's calling like an Oracle service, which ends up calling Postgres, and then and so on, so on, so on. Now, immediately when I looked at this trace, I thought, wait, so it's calling authenticate after calling cart service? Interesting. So, like even just using observability tooling with like a security perspective, you can gain things that were not really intended in the first place. So you can use these tools. It's like, okay, yeah. So something that's really cool is that inside each of these events, you have a lot of data. So looking at this is an HTTP server. So we're seeing like, oh, so this was a post request to this thing, and that's the URL. And here's some stuff about the client that's connected to us. So we're getting a lot of the context that we needed to understand what's going on. And like, this is like just one of the most popular open source tools for this. And it just right off the bat gives us something that is observability 101. Who's calling who, how many requests per second were happened, what's the average latency. But how many of us like yearned to have this simple a map to do like threat modeling, right? Like this is something that I looked at it and I was like, huh? So tracing gives you the breadth, like who's talking to who about what. And combining these two together, we have an interesting perspective. Again, observability tooling meant more for understanding, you know, the latency and debugging and the ins and outs of the system looked through a different lens, a lens of security. And when I first like learned about these, I learned about these from, you know, a developer hat. And I was like, oh yeah, cool. But then I donned the security hat and I was like, wait, what? Because let's take profiles. Like how many of us, even like it could be when you're doing like finding analysis, but it also could be when you're doing vuln research on your own. Building this understanding of which function is calling which, especially in dynamic languages, but not only, even just in Java, oh, we have magic reflection because Spring does things. It's a lot of pain. And you can have this kind of understanding for free. Or like tracing. So how many of us are like, yeah, we know that someone has built like a service map somehow, and it's behind some bearded guy on a whiteboard, but we can get that for free. And that made me mad because this has been going on for years behind our back and nobody told us. And not only that, there's standards. Like, these things have standards. Like the largest one is OpenTelemetry. And like they're a huge CNCF project. And they're like saying, oh yeah, so that's how you create traces and that's how you export them somewhere. And you can vendor shop. There are multiple vendors for creating and ingesting and visualizing traces and profiles and metrics and a whole bunch of stuff that at least I personally was not aware of. So yeah, I got envious and I got mad. So let's ruin someone's day. What we're gonna do now is channel our energy, and we're gonna run an RC. What we have here is we have the OpenTelemetry demo. So that's like a large project to demo like some of their capabilities. They've made like a nice microservices, shop. So you have the thing, and you have products, and you have recommendations, and checkout, and advertising, and all of that. So that's cool. So I took this very nice project, and I injected vulnerabilities into it because we destroy everything that we touch. And now we're gonna run the RCE. Now I'm a bit excited because what I did is I wrote like the exploit, and it was like 5 lines of code, and then I gave it to an LLM. And I asked it to make it more bro. And I did that 10 times. So I'm very excited to share the result with you. We're in. So yeah, we can do like an LS, and we can do like a PWD. Anyone run some command? ID minus A. Cool. An audience member suggested RMRF. I'm not that adventurous right now. So yeah, we're seeing it running as root, which is of course the best thing that you can do inside of a container, which will already tell you like, yeah, I need to have a conversation about security, which would not have happened if our better friends, well, that, yeah. So we just ruined someone's day. We called some alerts. We had some fun. So we're gonna take off our black hat now. I'm sorry. And we're gonna bring us back into our day has been ruined. So we need to understand someone has just done an RC on us, and we have to understand what happened. So remember how we needed to answer all of these questions and understand like, oh, what happened, where, do risk assessment, blah, blah, blah. So what I'm going to do now is I'm going to show you how you can use like tracing and profiling in order to get a lot of this context. So here's an example of like, okay, so I just got this request. It's a gRPC thing. Here's like the IP. Here's the method. Nice. That is very common. Now, remember how a profile is just a bunch of stack traces, as Keanu taught us? So we're seeing a get personalized add. We're seeing like a script engine eval and process builder start. For those of us who have been blessed to not have Java knowledge, that means there's some templating engine and someone did something weird, so it can run arbitrary code, and now someone ran some process. And just below it, we have like a trace view of what happened, who called who, and what did they do. So we're seeing this hitting our front end, and there's some gateway, and now we're in the get personalized add. There's some Postgres queries, and we're seeing some data about like what was actually happening in this request. And not only that, because we're good people and we inventoried this over time, we have a lot of runtime context that was built up. So we know that we're in Kubernetes. So remember how we had to understand like what the impact is and what could be potentially done? So cool. So this is the cluster. This is the namespace. So yeah, you can use all of your required knowledge to answer things like, oh, is this like the PHI environment? So even if this were more benign, would I still want to take care of this? Or is this something more, more benign, or is this more interesting? And not only that, because we've been good people, we could have inventoried this over time to gain understanding of like, oh, so this is my API inventory, but it's also correlated to like, here's my service maps and here's how they're talking to one another. And these kinds of things will really help you once we get to the point where how after every incident there's the favorite thing of having like a postmortem, and we're all looking forward to it to share and experience this together. So we have to answer a lot of questions like what happened, when, why, so we can use these kinds of things to answer these questions. And because stack traces and traces are something that observability, DevOps and technical people are familiar with, you can just use this information and give them these stack traces and give them these traces, and they'll figure out what to do. So, AppSec's hard. There's no way around it. Like, it's difficult. You still have a bazillion stakeholders to answer to. You still have like way too many vendors who do the same thing and you can't quite distinguish between them. And you need to do all of this triaging and all of these prioritization over and over and over and over again. But it's getting better. Especially if like you've been around for like 5-10 years, like the state of the art isn't snort anymore. Like, we have improved both in our tooling, but also in our understanding of what application security means. And especially like we're starting to make advances in collaboration, both inside of ourselves, like creating standards, creating formats so we can interoperate and talk to one another. So, thank you very much. I hope this was interesting. Either is like yeah, this is cool kind of thing. Or I hope this has also inspired you to like either make changes inside of your organization or, to push the needle a bit. Now, I believe you have some Q&A. You can still do the QR code for submitting questions. And if you want to talk, here's my email. Feel free.
All right. Thank you, Ben. So again, this is a reminder, we're in Theater 6 here. We take questions via Slido. There is one question in the DAC. We actually got two. And a reminder, you just go to sli.do and enter in the keyword BSidesSF 2025, and you'll be able to put in a question. So we've got two. Our first one here is, why can't AppSec give libraries or code that's sanitized or secured, removing vulnerabilities by design?
Okay, so if I understand the question, that is an amazing one. And like show of voice, how many here do crypto in some, like cryptography in some way? Okay, so some cryptography. Let's take SQL injection. SQL injection should not have existed in the first place. But what is the single most beneficial thing that has happened to eliminate SQL injections? Prepared statements. Prepared statements and ORMs are the single best thing that have happened to prevent SQL injections because they make doing the right thing so easy. Like, you need to make your life worse to do the right thing. And that is an issue of like API design. And we're not very good API designers for the most part. Like, as an industry, we're taking some times and some cycles to understand what kind of vulnerabilities are there. Just take a look at how we, take a look at like GraphQL queries. We've managed to do the problem again. Take a look at like requests to NoSQL databases. We've managed to do like NoSQL injections. Like, it takes each generation it's time to understand its mistakes of the previous and the previous generation's mistakes. So I think like the most obvious thing to do would be make better APIs and make better design choices.
All right, the next kind of question we got here is, does this kind of data require an agent?
Good question. So there are a few approaches to this. If you're looking at, how engineering and DevOps usually use this, there are a few methodologies. One of them is to introduce some SDK inside of your program. So that is most like APM, application performance monitoring solutions will do that. Like, you do a require or an import or something like that. And you can also establish like your own tracing or your own profiling events or whatever. There are other options. Some of that is auto instrumentation. And that is something that you configure your environment in some way that figure out how to inject these kinds of things. And over the past few years, especially, there's a movement towards eBPF-based instrumentation, which figures out, especially in platforms, where or specific platforms how to do these kinds of events without needing to, run like runtime level code.
So you showed a really nice RCE. What are
Thank
some
you.
other kinds of exploits we should be using profiling and tracing to look for, if any?
Good question. So there's a few. I can answer it in like the specifics. In the general, I think there's like a distinction between how you detect a vulnerability and how you investigate it. And I think that the jury is a bit still out on what kind of detections you can do. Some vendors are more, exploring this kind of space. And as time goes on, we'll figure out more and more things that we can actually do. As a tool for investigation, this will help you not only understand RCEs or the kinds of vulnerabilities that you can detect using these methodologies, but to also investigate any kind of finding that you have. Because, you have these kind of tools at your disposal to give you an understanding of, okay, so what is my environment? How did this request happen? What did it touch? What happened there?
So how do you trace an app and all the associated calls and services it depends on without access to the source code?
So that's a good question. As mentioned before, if you are the one who are pushing this, then some vendors will have options for either auto instrumentation or instrumentation through something like a sidecar, an eBPF, something like that. So you can solve this not through a source code kind of deployment, but through a more DevOpsy kind of deployment.
And how do you do this at scale? At the company that I work at, we only do this at about 1%.
That is one of the challenges of modern observability, handling this kind of scale. One of the reasons that I said that I think this can really help investigation, no matter what kind of vulnerability, is that to gain this understanding, you don't need to only find the interesting event. If you are building your inventories and you're tying them all together with these methodologies, you're doing that over time. You're like listening to what observability is saying, which is you don't necessarily care about like a specific point in time. You care about all of your accumulated knowledge. So that can happen over like weeks and months as you're building knowledge. Of course, having more is better, but I think like one of the challenges we're seeing, especially like now, is how to either expedite that or have more knowledge.
Assuming that you have an AI pen tester who has the same performance as a human pen tester, where is the most valuable place to introduce an AI pen tester in the business? Sounds like a hard one.
Okay. Where can be several kinds of where. I'm gonna try and answer this from, you have a bunch of services, which ones would be most interesting. So I would flip the table here and ask you, where would you like direct a human researcher? If you're like either doing it like, I don't care, find something, then that's your answer. But again, you most likely have an understanding of what is more important to you, and where if you were to find a vulnerability, where you'd be like, okay, and where would you be like, oh no, I'm stopping whatever I'm doing.
This next one has to do with open telemetry. How good is its instrumentation out of the box, meaning just no one going in there and manually instrumenting the application code? Where is the coverage typically missing in that scenario?
So OpenTelemetry is very good at covering some more of the common bases, and it's still an ongoing project. So first, I would it's a very large community project. So first, I would recommend you participate in it, and it also has a large governance around what's important to it and what to push next. So if you have cases that are specific to you, then you need to voice them so they will be covered. Some languages are more mature. For example, Java is relatively mature. Some are more new, like Go. So it's a bit depending, but they're very open about it, and progress has been impressive.
We went through all of our questions. Really good job. Thank you, Ben. And thank you, everyone, for attending this talk. Whoever's off here. Ben, will you be available for questions up in any of the access areas?
Wow, that's a great question. Yes, I would be available.
Okay, we encourage everyone. Everyone here is a participant, speakers and attendees alike. So really thankful to have you here.